Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for polynomials. In the previous session, we have discussed the factor and remainder theorem, and we did some good number of examples for establishment of remainder theorem. In this session, we'll be discussing some applications of remainder theorem. So let's begin the session. Now let's take the first question. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by these various polynomials. So in the first case, this expression or this polynomial is divided by x plus 1 and we have to find out the remainder. Now just have a quick recap of remainder theorem. If a polynomial px, in this case suppose it is px, is divided by x minus a, here x minus a is x plus 1, then the remainder is pa. So in this case the remainder should be p of minus 1. Okay, so let's find the remainder by this way, and we are not going to perform the actual division. So if x plus 1 is 0, x is equal to minus 1. So suppose it is px, which is x cube plus 3x square plus 3x plus 1. Now what will be the remainder if this expression is divided by x plus 1? Let's calculate p of minus 1. And what p of minus 1 is? P of minus 1 is the remainder when px is divided by x plus 1. Okay, so just put the value of x as minus 1. It's minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. So it's minus 1 plus 3 minus 3 plus 1. So we are getting 0. That means if x cube plus 3x square plus 3x plus 1 is divided by x plus 1, the remainder is 0. And how we are getting the remainder by short method? It's by remainder theorem. What we are doing in the remainder theorem? We are getting the we are putting the value of x as minus 1 in this expression and getting the value, and this value is nothing but the remainder when this expression is divided by this. Okay, so I hope you are clear. Let's take the next example. Now we have to find the remainder when this expression is divided by x minus half. So let's px is x cube plus 3x square plus 3x plus 1. Now we have to find out p of 1 by 2. See, this is x minus a, that means a is half. So we have to find out pa, that is p half. So it's okay. Now let's calculate it. It's 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. So let's take LCM. It's 1 plus 4 2s are 8 and 2 3s are 6 plus 2 4s are 8 and 4 3s are 12 plus 1 8 is 8 and it's 8. So what we are getting over here? 6 plus 1 7, 7 plus 12 19, 19 plus 8 is 27. So it's 27 by 8. So if x cube plus 3x square plus 3x plus 1 is divided by x minus half, we will be getting the remainder as 27 by 8, and we have calculated this remainder by remainder theorem but not by actual division. Okay, so remainder theorem is a very quick way to find out the remainder when one polynomial is divided by the other. Okay, let's do the next one. Now let's find the remainder when this expression, that is px, is divided by x. Okay, so here it is x is x minus 0, that means x minus a, where a is 0. That means we have to find out pa, and pa is nothing but p0. Okay, so now put the value of x as 0. It's 0 plus 0 plus 0 plus 1. Okay, so we are getting 1 as remainder in this case. That means if x cube plus 3x square plus 3x plus 1 is divided by x, we will be getting remainder as 1. Okay. Now we have to find out the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus pi. Now x plus pi, we compare it with x minus a. So a is minus pi. Now we have to calculate p of a, that is p of minus pi. This way you can calculate the value of a by both the methods. You can write x plus pi as 0 and get the value of x, or you compare x plus pi with x minus a and you can get the value of a. So we have to calculate the value of p of minus pi. So put the value of x as minus pi. So it's minus pi cube plus 3 into minus pi square plus 3 into minus pi plus 1. So it's minus pi cube plus 3 pi square minus 3 pi plus 1. So if I divide x cube plus 3x square plus 3x plus 1 by x plus pi, I'll be getting this expression as remainder. Okay, so how easy the remainder theorem is. Okay, let's take one or two more examples. Now in this case we have to find out the remainder when this expression is divided by 5 plus 2x. Now we have to find out the value of a. So there are two methods. First of all, equate it to 0. So we'll be getting the value of x as minus 5 by 2, which is the value of a. Okay, and else you can compare it with x minus a. So it's 2x plus 5 and we compare it with x minus a. Okay, so we can write 2x plus 5 as x plus 5 by 2. Okay, that means a is equal to minus of 5 by 2. Okay, so a is minus 5 by 2. Now we have to calculate PA, or we can say P of minus 5 by 2. So I just put the value of x as minus 5 by 2. Minus 5 by 2 square plus 3 into minus 5 by 2 plus 1. So minus 5 cube is minus 125 and 2 cube is 8 plus 5 by 2 square is 25 by 4 and 25 into 3 is 75. So it will be 75 by 4 and minus it is 15 by 2 plus 1. Okay, so let's take LCM. So it's minus 125 plus 4 2s are 8 and 2 into 75 is 150 minus 2 4s are 8 and 4 into 15 is 60 plus 8. Okay, so what I'll be getting is minus 125 plus 150 is 25, 25 plus 8 is 33 and minus 60 plus 33 is minus of 27. So I'm getting the remainder as minus 27 by 8. Okay, I hope you are clear. So we calculated the remainder by putting the value of x as minus 5 by 2. Okay, now let's take the new concept. Now let's discuss the problems based on factor theorem. In this problem, we have to use factor theorem to find whether polynomial gx is a factor of polynomial fx or not. So first of all, let's have a quick recap of factor theorem. What factor theorem is? If px is any polynomial of degree greater than or equal to 1. Suppose I have a polynomial px. Okay, and the degree of this polynomial is 1 or greater than 1 and a is any real number. Now x minus a is a factor. I just write it over here. X minus a is factor of px if pa is 0. Okay, so if I put the value of x as a, and if I'm getting the value or the solution as 0, that means x minus a will be factor of px. Or in otherwise we can say, if pa is 0, then x minus a is factor of px. Okay, so let's do this problem by this concept. Now let's try to find out whether gx is factor of fx or not, and we are going to use factor theorem. So this is x cube minus 6x square plus 11x minus 6, and it is x minus a. So here a is 3. That means we have to calculate f3. So if I get f3 as 0, in that case x minus 3 will be a factor of this, and if I am not getting f3 as 0, in that case x minus 3 will not be a factor of this. Okay, so let's calculate f3. So it's 3 cube minus 6 into 3 square plus 11 into 3 minus 6. So it is 27 minus 3 3s are 9, 9 6 are 54 plus 33 minus 6. So it is 33 plus 27, 60 minus 54 minus 6, that is 60 minus 60 is 0. That means f3 is 0. Okay, that means x minus 3 is a factor of x cube minus 6x square plus 11x minus 6. It was a simple application of factor theorem. Okay, and let's do the next problem. Now in this question, fx is 3x4 plus 17x cube plus 9x square minus 7x minus 10, and gx is x plus 5. Now we have to find whether x plus 5 is factor of fx or not. So what is the first step? First of all, we have to calculate the value of a. There are two methods of calculating the value of a. If I compare gx by x minus a, I can get the value of a, which is minus 5. Or if I put the value of x plus 5 as 0, then whatever the value of x, it will be the value of a. So it is minus 5. Now that means we have to get the value of fa or f of minus 5. So f of a or f of minus 5 is equal to 3 into minus 5 raised to 4. I just put the value of x as minus 5. Then plus 17 minus 5 cube plus 9 into minus 5 square plus minus 7 into minus 5 and then minus 10. Now we have to calculate this. So minus 5 raised to 4 is 625. So it is 3 into 625, that is 1875. So it's 1875 minus, it's 17 into 125, and it will be negative since negative raised to 3 is there. So it's minus of 2125. Then minus 5 square is 25, and 25 into 9 is 225. Then minus 7 into minus 5 is plus 35, and it is minus 10. So what will be getting the final answer as 0. That means gx is factor of fx. Why? Because I am getting 0 when I put x is equal to minus 5. Okay, so further it's an application of factor theorem. Let's do one more problem. Now in this question, fx and gx are given, and we have to find out whether gx is a factor of fx or not. So further we'll be using factor theorem. Let's calculate the value of a. So compare x plus 3 by x minus a. We will be getting a as minus 3, or we can put the value of x plus 3 as 0. So whatever the value of x, that is minus 3, will be the value of a. So we have to calculate fa or f of minus 3. So let's put the value of x as minus 3. So it's minus 3 raised to 5 plus 3 into minus 3 raised to 4 minus 3 raised to 3 minus 3 square plus 5 into minus 3 and plus 15. Okay, now let's calculate. 3 raised to 5 is 243. So it's minus of 243. Since odd power of negative is there, here even power of negative is there, so we'll be getting 3 raised to 4 into 3, that is 3 raised to 5, but it will be positive. So it's positive 243. Here odd power of negative is there, so we'll be getting a negative value. So 3 cube is 27, and minus 27 it will be, and further minus 27 into minus will be getting plus 27. Here it's minus 3 square, it will be 9. 9 into minus 3 minus 27, then plus 15 minus 15. So everything will be cancelled and will be getting 0. That means gx is factor of fx. When we put x is equal to minus 3, we will be getting the value of fx as 0, or we can say f of minus 3 is 0. That means gx is factor of fx. Okay. What if we are not getting 0 at this place? So if we are not getting 0, so whatever the value is, that is known as the remainder if gx is divided by fx. Okay, so if 0 is the remainder, then gx is factor of fx. If it is not remainder, whatever the value is there, it will be remainder if fx is divided by gx. Okay, now let's see this question. We have to calculate whether gx is factor of fx or not, and further we are using factor theorem. So first of all, let's find out the value of a. Compare x minus 7 by x minus a. We will be getting a as minus 7, or the alternative method is put x minus 7 as 0. Whatever the value of x will be the value of a. So let's calculate fa, or we can say f of 7. So put the value of x as 7. So it will be 7 cube minus 6 into 7 square minus 19 into 7 plus 84. So 7 cube is 343. 7 square is 49. 49 into 6 is 294 minus 19 sevens are 133 plus 84. Okay, so what we are getting as a final answer? It is 0. That means further gx is factor of fx. Since by putting x is equal to 7 in this expression we are getting 0. That means x minus 7 is a factor of x cube minus 6x square minus 19x plus 84. Okay, I hope you are getting my point. Now let's see this question. fx is 3x cube plus x square minus 20x plus 12, and gx is 3x minus 2. Now we have to find out whether gx is factor of fx or not. So first of all we have to calculate the value of a. So let's compare 3x minus 2 to x minus a. Okay, so I can write it like this. I'm comparing it to x minus a, so a will be 2 by 3. Or we can calculate the value of a by putting 3x minus 2 as 0. So x will be 2 by 3. Now we have to calculate the value of fa, and fa will be f of 2 by 3. So let's put the value of x as 2 by 3 in this expression. So it's 3 into 2 by 3 whole cube plus 2 by 3 square minus 20 into 2 by 3 plus 12. So it is 3 into 2 cube is 8 and 3 cube is 27 plus 4 by 9 minus 40 by 3 plus 12. Now let's take LCM. It's 8 plus 4 minus 3 into 3 is 9. So and 3 into 40 is 120. Then 1 into 9, 9, and 12 nines are 108. So it's 108 plus 4, 112, 112 plus 8 is 120. Now 120 minus 120 is 0 by 9. So finally we'll be getting 0. That means if I put x as 2 by 3, I'm getting the value of this expression as 0. So further I can say 3x minus 2 is a factor of 3x cube plus x square minus 20x plus 12. If I didn't get 0, then 3x minus 2 is not a factor of this expression. Okay, so I hope you are getting my point. Now in this question, let's find whether gx is factor of fx or not. So first of all, let's calculate the value of a. It's minus 2x plus 3. I put it equal to 0. So 2x is equal to 3. That means x is equal to 3 by 2, which is the value of a. Okay, you can get the value of a by this method, or you can compare this expression to x minus a. In both the cases, you will be getting the value of a as same. Okay, so now let's calculate f of a, which is f of 3 by 2. So just put the value of x as 3 by 2. So it's 2 into 3 by 2 whole cube minus 9 into 3 by 2 square plus 3 by 2 plus 12. So it's 2 into 3 cube is 27 and 2 cube is 8 minus 9 into 3 square is 9 and 2 square is 4 plus 3 by 2 plus 12. Now let's take LCM. It's 8. 2 into 27 is 54 minus 4 into 2 is 8 and 2 into 81 is 162 plus 2 4s are and 4 3s are 12 and 1 8 and 12 8 is 96. So what we'll be getting is, it is 162 minus 162, that is 0. So further we are getting, so we can say 3 minus 2x is a factor of 2x cube minus 9x square plus x plus 12. Okay, why? Because we are getting the value of this expression as 0 if we put x as 3 by 2. Okay, so friends, we have done a good number of problems of factor theorem and remainder theorem. In our next session also, we'll be taking some applications of or I can say some difficult problems based on factor and remainder theorem. Till then, do revise this session so you'll feel better in the next session. Okay, bye bye.